Okay, so in this tutorial we're going to have a look at the process of taking an injection molded component. In this case it's the back of a knife, and building a molding tool around it. So in this particular instance we're going to create a two-part mold just with a simple core and a cavity. So I'm going to walk you through some of the steps that you need to go through in order to set that up. So I'm looking at the finished part here that I want to create the mold for, and then the first thing that I do is create a new empty part. So I'll do that first. Then I need to insert a copy of that part that I was just looking at inside this part, because this empty part is going to become my mold tool. So I go insert part. The part's already open, so it will be in this list of parts here. If the part wasn't already open, I could browse and find the part on the disk. But there's my part that I want to create a mold round, my knife back body. And then I'm just going to allow the system to insert it into the default location. So I'll just click on the green tick. So I now have a copy of that part design in this new part that will become my mold tool. So primarily, or almost entirely, I'm going to be working in the mold tools menu. So if you can't see the mold tools tab, you'll have to right click on another tab and go down to tabs and just make sure that it's active in there, and then it should appear. So one of the first things that we do is click on this button here, which is insert mold folders. That doesn't really seem to have too much of an effect initially, but as we begin to build our mold, we begin to build the surfaces and lines that will help us create our mold, that just allows us, or it allows the system to organize those things that we're creating into specific folders. So we'll see the effect of that a little bit later on. You don't see an immediate effect. So after that, the first real order of business is to scale our part, because almost all plastics that you may use for your injection molding will shrink slightly as they solidify. So we have to scale up our part to account for that shrinkage. So let's imagine in this case I want to scale the part up to 102% of its current size. What I would type in this box would be 1.02. So we're expressing a percentage, but we're expressing it as a ratio. So 1.02 is 102% of the original size. So we've scaled it up by 2%. And when I click on the green tick here, you should be able to see the part grow slightly. There. So the part got slightly bigger. The part got 2% bigger, to be precise. So we have to account for that, and that will depend on which plastic we're using for our injection molding process. You can research that and look at shrinkage rates and apply a suitable one. So generally speaking, we're going to work from where we were at scale there over to the right, addressing most of these icons. So the next icon to address is to create some parting lines. And what we have to tell the system first when we do this is what direction is the mold going to open in, or to put it more succinctly, what direction is the part going to be pulled away from the molding. So handily I have the front plane that I can use as a reference there. Then it's often wise to do some draft analysis just to check on the status of your draft in your part. You can see that this part's not 100% drafted in every single area. There are little areas here, little yellow areas that require some draft. That's not really a barrier to setting the mold tool up. The nice thing about this process is I can get the mold tool set up and designed, and then go back into the part and make some changes to it, and those changes will run through the mold. The next time I open the mold, it will realize that I've made a change, and those changes will be reflected in the mold. So I'm going to continue anyway. And what we have to do here is we have to pick a closed loop of edges or lines to define where the upper mould tool and the lower mould tool will split apart from each other. And the general recommended set of lines to use is where the draft flips from positive draft to negative draft. So that's easy to find here. It's where the faces flip from red to green. It's a little bit more interpretive when you get to the yellow areas where it's saying requires draft. You have two choices. You can go kind of the top route or you can go the bottom route. And it's often worth kind of experimenting with that, coming back in and changing it to the alternative and seeing what effect that has. But let's begin our journey around the outside of the part. So I'm going to click here, and the system suggests the direction that I might want to go in. So click there, and you can see the edges being collected in this little box. In some cases you can let the system automatically choose these lines, but it's arguably better to be in control yourself and to manually go around and pick some of these lines. So just going round, picking where I'd like the two halves of the mould to split from each other. I missed an edge there, so just be careful of that. If you're getting errors at the end here, you may have some small edges that you miss as you go around. So it's worth kind of zooming in and out a little bit if you're experiencing problems. So I'll pause at this point. So as I said before, when you get to yellow areas, which are areas that require draft, you often have two choices. So I could go in this direction and choose these edges at this side of the non-drafted area, and that would produce one shape of mould, core and cavity. Or I could go down this route and go along this edge, and depending on which one I choose, I'll get slightly different looking mould tools where the split line between those two mould tools is slightly higher or lower within the setup. So let's have a little think about this. If this part is going to shrink inwards, it might be wise to choose these lines here. But as I say, you're not locked into this decision. You can always come back to this part of the process and modify your selection. So if you're having problems later on down the line, you can come back into the parting line feature. This is just a normal feature like any other feature, so you can go back in and edit feature just like you can with most other features. So I'm going to accept that, and hopefully we won't have any problems. I have actually missed a line, and I can see the line that I missed. So if you miss a line, you'll probably get this warning symbol. If you hover over for long enough, you should get a tooltip that pops up and kind of tells you. I think my system's struggling here because I'm recording the screen. There you go. Warning, selection failed. Parting line selected is open. That just means it does not form a closed loop of edges. So there must be a little open section in there. So I'll go back in, edit feature, and I can see which line is missing. That one there. So hopefully that will have fixed everything. Yeah. So it's happy now. So I have a closed loop or a closed set of edges there. So I can move on to the next order of business, which is creating any shut-off surfaces. So what this means is, if I have any holes that pass through the part, which I do here, we need to cap those holes off in order to give the upper and lower mould a surface where they will meet each other to create that hole. So, shut-off surfaces. Now, the system does have a good attempt of selecting where these shut-off surfaces might be used. Because of my design and because of some errors in my design that I may want to go back and fix at some point, it's chosen way more shut-off surfaces than I require. The only real through hole or true through hole through my part is this hole here. I can see that these are just little ripples or indentations in my part. So what I'm going to do, I'm going to clear all the auto selected edges, So I'm going to right click here and say clear selections, and I'm going to go in and manually pick the edge that I want. So that would be that edge there. And then I should just be able to click on this icon and it will run round any tangent edges and create a shut-off surface that caps that hole off. So select that, and there it is, the shut-off surface. So now we can move on to the next item along in the menu. So that would be parting surfaces. And what this does is it looks at our parting line that we previously created, and it projects outwards away from that line a cutting tool, if you like, that will chop our mould into its upper section and its lower section. So those two sections are called the core and the cavity. The cavity is the one that has a kind of indentation in it, so material kind of machined away, and then the core has material that sticks outwards. And this projected surface is going to act like a cutting tool to split one block of material into the core and the cavity. So we need to project this outwards quite a long way in order for it to be big enough for to clear our moulding tool. So again, you might have to play with these settings slightly just to get the figure that's best for you. But we'll see in the next step. What I'm going to do is I'm going to draw a rectangle around my part, and that will be the external size of my two mould tools. So this projection, this parting surface, has to project outwards far enough to be able to contain that rectangle. So this may be a little bit of trial and error to get this correct. I'm going to go for 40 millimeters in all directions in my case. I may come back in here and change this value. And there's various options here. I'm going to leave them all set to their default because that tends to be what works the best in most cases. Although I can see I may have some issues here where it's taking this curve and it's kind of accentuating it there, which is not ideal. So maybe I might want to play with some of these options, the smoothing options maybe. That might be more suitable in my case, although I'm still getting some geometry there that is unfavourable. So again, I'd encourage you to kind of play with these options and see what difference it makes. So I've just played with the smoothing distance option there, and I got something that was more useful there, because ultimately what we're going to do is we're going to try and machine this mould from a block of material. So you have to create geometry which is machinable, for want of a better word. And that, with an overhang there, would be very difficult or impossible, more likely, to machine. It has that tight sort of overhang there. So this is why I had to play with some of these settings to try and get something that's a little bit more achievable using our machining techniques that we're going to use later to machine these mould halves. So that seems okay. I'm not going to drill down too much into that, but yeah, there's various options there that you can adjust, and you can see the effect that they have, and you can always come back in here and make a change if you're having problems later on. So let's accept that parting surface, and then at this point we can investigate a little bit and we can see the effect that those mould folders have, because when we clicked on that button they didn't seem to really do anything. So if we have a look inside surface bodies now, you can see this is the effect that we had when we clicked on that button. It created, or rather SolidWorks created, 3 little folders within our surface bodies folder, and that organizes the bodies that we've created during this process into bodies that are related to the cavity half of the mould, bodies that are related to the core half of the mould, and bodies that are related to the parting surface, to split those two moulds in half. So that's what we were doing, and these are color coded. So if I right click on one of these and say isolate, you can see that all the cavity related bodies are colored in green, and then all the core related bodies are colored in red, and then I believe the parting surface just stays in that grey colour, because that is neither part of the cavity or the core. It is used for both, so it doesn't really have an affiliation to one or the other. So let's continue on. So now we're going to click on the next button along, which is Tool in Split, and this is the step that I just described as we were creating this surface here. I'm going to draw a rectangular shape to represent the external sizes of my mould tool. So I need a plane to draw on, and the plane that we used as reference for our split direction is the most wise to use. So I'm going to use the front plane there. I'm going to get my rectangle tool and just kind of quickly sketch out the rough size and shape. And then there's two ways really that we could define this. We could put some smart dimensions in and just give it a simple kind of length, whatever we would want, and a height. In fact, this is probably the way that I'm going to do this. But then it might be nice to relate it to the size of the knife design slightly. So maybe put an offset from one of the points on our knife, if we can grab one of these. I want a point really, not a line. That's not bad. So maybe keep that as a 20 offset. What I will have to be careful of there, if I change my design massively, then the design may poke out through the edge of this box, so I may have to just keep an eye on that. So let's try and put an offset here as well, if possible. It might not be possible. Can I pick up on a point on the edge of the knife maybe? This will depend on your design quite a lot. Maybe I can pick up on that point on the corner that I referenced before. Yeah, it's been difficult. I'll try it down here instead. Zoom in a little bit. There we go. So maybe have that as 20 as well. Maybe a little bit more, just to try and centralize where the design is in the middle of the mold. That's not too bad. I could tweak this a little bit more just to try and equalize up the sides there. I'm reasonably happy with that, or rather I will be when I've adjusted that, and maybe tweak this a little bit more. So you'll have to decide on these numbers yourself, but you can see I'm trying to get somewhat constant offset all the way around this design, and I could use this offset method all the way around, so I could put another offset over here and then I wouldn't need these numbers. But given that we're going to have to machine this from a block of material, it would be nice to have a round number, so a number that doesn't have many trailing decimal places for the overall width and the overall kind of depth of the mold. So that's why I wanted to set these manually and then just put a couple of offsets in there. So I'll OK that sketch, and then you'll need to rotate your view to kind of see what's going on and appreciate what's going on. So from that sketch plane, the system is going to extrude essentially in direction 1. So I believe this is the upwards direction. Let's adjust it. Yep, so that's direction 1. That will create our core half of the mold. So that has to be deep enough to have enough mold material there to accommodate that core, and then we'll see later to accommodate some cooling channels and some fixture holes and things like that. So 25 doesn't look too bad in my case. I'm going to leave that at 25, and then we have an extrude in the opposite direction, which is going to be the material that the cavity half of the mold is created from. So generally speaking, the only things that we have to play with in here is the distances. Because of all the other setup work that we've already done, the system is quite good at recognizing the shut-off surfaces and the core surfaces and the cavity surfaces. So you can see it's auto-populated all of these selection boxes. But we could do that manually if needed. We have access to all the surfaces here, So if one of these was blank, we could kind of find the appropriate surface to put in that particular box. But the system's normally quite good at that. It will auto fill those boxes in for you. So we'll click on OK. And then it's not immediately obvious, but we have actually now created our two halves of our mould. So the way that we can check on that is if we go into solid bodies, we have that original part design. It's kind of hidden away inside these two blocks. And then we have two extra solid bodies that we didn't have previously, one called tooling split 1 and the other one called tooling split 1 brackets 2. Now it's probably better to rename these in a second so that we call them core and cavity, but let's just have a look at them first. So right click and isolate. So that would be our cavity half of our mould, the half of the mould that has a kind of indentation in it. And then if we exit isolate and have a look at the other half of the mould, that will be our core half of our mould. The half of the mould that has a kind of protrusion that sticks out from the mould surface. So let's just name those appropriately now. So is that my cavity? Yes, that is my cavity. So cavity. Is that my core then? Yes, it is. You can see it's kind of sticking downwards that way. So core. And then I can take a save of this whole setup. Now, make sure that you save this in with your other parts. Don't put this in its own folder. Just save it in the common folder that has all the other bits of your knife design in there. And let's call it Mould Tool Setup. Seems quite descriptive. And then what we can do, if we need a copy of each one of these mould tools, so the mould cavity and the mould core, in an individual part, because at the moment they're in a multi-body part, both the cavity and the core exist within this single part. So if we need them for manufacturing purposes or CAM, program writing purposes, we can save them out very much in the same way that we've done previously when we've been using multi-body parts to create various designs. Our mouse design was one of these. So the way that we save out bodies from a part is we right click on the solid bodies folder, click on save bodies. Then we're confronted with this screen where the system identifies how many solid bodies are inside this part, and it's asking us which ones of these do you want to save out into their own individual part files. So we don't want to save the actual moulding itself. We want to save this half of the mould tool and this half of the mould tool only. That other one, as I say, is the design, the shape that we want to mould. So we don't need to save that out. And then if we just want to double check that these are going to be saved in the correct location, then we can double click on one of the names and just check that it's going to put them in the folder that we require. So I'm just going to drop these in my one folder that I've been working in all the time. So I don't really need to change anything there. It's just a check that it is actually going to save these out into the correct folder. And then I can click on the tick there and it should do its thing and create two new parts. I may get this pop up talking about templates for parts. If you just click on no, that's not going to cause much problem. So it should have created those. So here we are. There's a cavity part file that's now open in the background. There it is. And there should be a core part file that is also open in the background in SolidWorks. So that's the basics of how we create a moulding tool from a part design and then end up with two genuine parts that we can then use, usually for manufacture, of those two halves of the mold tool. So that's what we have now. Okay, that's the end of this tutorial.